Why are conditionals and control flow so vital in Java programming? Let's conjure up an image to help us understand better. Picture yourself in the heart of a colossal, bustling metropolis, full of winding alleyways, towering skyscrapers, and streets teeming with people and vehicles. Now, imagine attempting to navigate this vast urban landscape without any traffic lights, signs, or rules. Imagine how chaotic it would be. There would be cars and pedestrians crossing paths at intersection with no clear indication of which direction to go. The streets would be filled with a cacophony of honking horns, screeching brakes, and people shouting. The risk of accidents would skyrocket, and the city's pace would descend into a slow, grinding halt as everyone struggled to find their path. This scenario sounds disastrous, right? Now let's try to draw a parallel to the world of programming. Writing code without conditionals and control flow would be similar to navigating through this city without any order. Just like a city needs traffic lights and signs to regulate the flow of vehicles and pedestrians, programming needs conditionals and control flow to manage the progression of code execution. Conditionals are the traffic lights of programming. Just like traffic lights manage the flow of vehicles by displaying different colors to indicate when to stop, go, and proceed cautiously, conditionals manage the flow of a program. They determine whether certain sections of the code should be executed or skipped based on specific conditions. Control flow, on the other hand, is akin to the traffic signs and rules in our city analogy. They guide the code, deciding the sequence and flow of instruction execution. Loops, for example, are like roundabouts, directing the code to execute the same set of instructions multiple times until a certain condition is met. Decision-making statements like if, and else are like arrows at intersections, guiding the code down different paths based on the values of certain variables. The use of conditionals and control flow in Java provides structure and order to our code. It facilitates efficient and effective execution, preventing the chaos that would ensue without them. They guide our code safely and surely to its destination. The same concept applies to programming. Conditionals and control flow in Java are like the traffic lights and signs that guide your code to its destination. Dive into the fascinating world of Java, where you'll find conditionals serving as the backbone of decision-making. Conditionals aren't just small fragments of code. They are incredibly dynamic tools that allow your program to examine variables and choose a course of action based on the conditions you set. Imagine embarking on a journey through a complex labyrinth. You reach a crossroad where your program has to decide which path to follow. It's not just a simple turn left or right decision. It's a calculated choice that guides the program's execution. To execute these decisions, Java provides several conditional statements, the most common being if, and else. Each of these statements performs distinct roles in the decision-making process. They are like the different tools in a Swiss Army knife, each with a unique function and purpose. Let's begin with the if statement. This is where the magic starts. The if statement functions as a gatekeeper, examining a condition to determine if it's true. If it is, block of code within the brackets springs into action, executing the instructions written there. The if statement is the first checkpoint in the decision-making process, the initial scrutiny of the condition to determine the program's direction. However, the journey doesn't end if the condition isn't met. If the first if condition isn't satisfied, the program doesn't just stop. Instead, it skips to the next part. The program moves forward, always seeking a path to follow, a directive to execute. This is where the else-if statement comes into play. The else-if statement is like the second gatekeeper, providing an opportunity for additional conditions to be examined if the initial if statement wasn't satisfied. It's like a second chance for the program to locate a direction. The else-if statement broadens the scope of the decision-making process, providing multiple possibilities for the program to follow. Finally, we have the else statement. This is the final stop, the plan B, when none of the if or else if conditions are met. Think of it as the safety net of the program, always there to catch any unmet conditions. The else statement serves as a default course of action, ensuring that even if no specific conditions are met, the program has a clear path to follow. In the intricate and fascinating world of Java, conditionals play a pivotal role. They are the compass guiding the program, the decision makers that determine the course of the program based on the set conditions. The if, else if, and else statements each play critical roles, working together to guide the program with precision and efficiency. The else statement, on the other hand, serves as a default action when none of the if or else if conditions are met. To control the flow of a program, Java uses loops such as for, while, and do while. When we delve deeper into the programming world, we encounter this marvelous technique called looping. It's an essential tool every programmer must have in their arsenal. Looping is a technique that lets you run a piece of code repeatedly until a certain condition is met. In Java, there are primarily three types of loops, and today we are going to discuss each one of them in detail. The first one is the for loop. Think of it as a repeating cycle with a defined start and end point, like a runner on a circular track. He knows where and where to end. A for loop is used when you know how many times you want to repeat a block of code. It consists of three parts: initialization, condition, and iteration. The initialization part is where you set your starting point. The condition is your end point. Until this condition is met, the loop will keep repeating. Lastly, the iteration, where you define how you want to get to the end point. It's like defining the steps the runner takes. One step at a time, two steps, or maybe even three. Next up, we have the loop. This loop repeats a block of code as long as a specific condition remains true. It's like a tediously long movie. As long as the popcorn and soda last, you remain seated. The moment they finish, you get up and leave. Unlike the for loop, the while loop doesn't have a specific starting and ending point. It will keep repeating until the condition you've set is no longer true. It's a handy tool when the number of repetitions is unknown. Finally, let's discuss the do while loop. This loop is quite similar to the while loop, with one key difference. It ensures that the block of at least once before checking the condition. It's like trying a new dish at a restaurant before deciding whether you like it or not. You can't make a judgment without having a taste first, can you? The do while loop is perfect for situations where the block of code needs to run at least once. It first does what it's supposed to, then checks the condition to decide whether to keep going or stop. These three types of loops in Java have their own unique properties, yet they all serve the same purpose: to repeat a block of code until a specific condition is met. By understanding how they work and when to use each one, you can effectively control the flow of your program and make your coding life a whole lot easier. The do-while loop is similar, but it ensures that the block of code executes at least once before checking the condition. Now imagine you have a collection of items, like a deck of cards, and you need a way to organize and manage them. In Java, this is where arrays and array lists come into play. An array is a fixed size, ordered collection of elements of the same type. It's like a bookshelf with a specific number of slots where you can store your books. The first book you place goes in slot 0, the next in slot 1, and so on. However, once the array size is set, it can't be changed. Array lists, on the other hand, are dynamic. They're like magical bookshelves that can expand or shrink as needed. They're part of Java's collection framework and can store objects, whereas arrays can only store primitive data types. To summarize, conditionals and control flow are the traffic lights and signs of your Java program, guiding your code's execution. Let's dive more into these concepts. Conditionals are analogous to the decisions we make in our daily lives. For instance, if you wake up and it's raining outside, you might decide to carry an umbrella. In Java, conditionals operate in a similar fashion. If a certain condition is met, then a specific action is carried out. Control flow, on the other hand, dictates the order in which your code is executed, much like traffic signs guide the flow of vehicles on the road. Now let's switch gears and move on to arrays and array lists. Consider the analogy of a large, sprawling library. Without any system of organization, finding a specific book would be a daunting task. That's where arrays come into play in Java. An array is a static, ordered collection of elements of the same type. It's like a shelf in the library, holding a specific of books. However, what if we need more flexibility? What if we need a collection that can dynamically resize itself as we add or remove books? That's where array lists come into the picture. Array list in Java is a resizable array that can grow or shrink dynamically. It's like a magical bookshelf that expands to accommodate new books and contracts when books are removed. Understanding arrays and array lists in Java is crucial because they allow us to efficiently store and manipulate data in our programs. Mastering these concepts might seem like learning to navigate a new city. Picture yourself as a newcomer in a bustling metropolis. At first, the city's sprawling layout, the dense network of streets and alleys, the hustle and bustle, all seem daunting. But as you spend more time, you start to understand the city's rhythm, its traffic patterns, its shortcuts. Slowly, the city becomes less overwhelming and more familiar. And one day, you realize you're no longer a newcomer. You're zipping through the city streets like a seasoned dweller, navigating with ease and confidence. This transformation is very much like the journey of learning Java programming. At first, concepts like control flow, arrays, and array lists seem overwhelming, but with diligent practice and repetition, these concepts will start to make sense. They will become less of an enigma and more of a tool to be leveraged for efficient coding. In the world of Java, understanding conditionals, control flow, arrays, and array lists is a game changer. So buckle up, keep practicing, and soon you'll be writing code that's as smooth and efficient as a well-oiled machine.